Welcome to the YouTube channel, Mr. Rafa Online Tuitions. Please don't forget to subscribe to the YouTube channel, Mr. Rafa Online Tuitions, and click on the notification button so that whenever I upload the video of this nature, you'll be the first one to watch and learn. This is mathematics in my DNA. Mathematics Paper 2 GCE 2024. Section A, question 1. A box contains 6 identical beads, 2 of which are red and the rest are green. 2 beads are selected at random from the box, one after the other without replacement. A1, draw a tree diagram to illustrate this information. A2, calculate the probability that the beads selected are of different colors. Total number. We have the total number of beads, which is 6. Okay. For the red beads, it is 2. So we have 2 red beads. Now, what about the number of green marbles? So now they have said a box contains 6 identical beads, 2 of which are red and the rest are green. So what we are going to do is we are going to subtract. We are going to say the total number of beads, which is 6, minus the red beads. We are going to have 4. So green, we have 4 green beads. So from there now, 2 beads are selected at random from the box, one after the other without replacement. So we are going to draw a tree diagram. So a tree diagram, we have, so this is the first picking, first selection, then we have second selection. So now on the first selection, we have red, we have green. On the first selection, suppose a red bead was picked. So what is the probability of picking a red bead? So probability of picking a red bead is equal to number of successive outcome divided by total number of successive outcome divided by total number of possible outcome. So the successive outcome of red is 2. So we have 2 divided by the total possible outcome, it is 6. So it will be 2 over 6. Suppose in the first selection I've not picked red, I've picked green. The probability of picking green, so there are 4 green beads divided by total number of beads, which is 6. So this is the first selection. Let's go to the second selection. Second selection, we have red, green. So suppose if I've picked my first selection, suppose my first selection was red. Okay? Remember the question without replacement. If I've picked red, kirapirula okuba ati ama red yachiba abiri muri box ero nafumyamu red automatically mwala ashara red and the total number of beads will remain 5. Okay? The total number of beads will be 5. Then we'll remain with 1 red. So now in the second selection, suppose I pick another red. So I'm remaining with 1 red and the total number of beads is 5. So the probability to be 1 over 5. That is my second selection. Suppose I pick a red bead and the green in the second selection. So how many green do I have? 4. So the probability to be 4 over the remaining beads, it is what? 5. Now, if I have picked, if my first selection was green, then I pick red. So the probability of picking a red, the total number of red beads is 2. So it will be 2 divided by the remaining beads is 5. Suppose I pick in my first selection green and second selection green. So there were 4 green beads. If I pick one without replacement, I will remain with 3. So the probability of picking a second green bead, it will be 3 divided by 5. So that is the probabilities. Let us look at the outcomes. So what is the probability of picking red? Red. So probability of red, red. So the first red, it is 2 over 6 times 1 over 5 equals 2 there, that is 1, 2 there, it is 3. So it is 1 over 15. So what is the probability of picking red? Green. Probability of picking red, green. So red is 2 over 6 times green is 4 over 5. So the answer is 2 there, it's 1, 2 there, it is 3. So 1 times 4, it is 4 over 15. Okay, we go to the second branch. What is the probability of picking green, red? Probability of green, red. So green is 4 over 6 times red, it is 2 over 5. So there we have 2 there, it's 1, 2 there, it's 3. So we have 4 over 15. So probability that it is a green, 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 green. So the first green is 4 over 6 times the second green, it is 3 over 5. So 3 there it's 1, 3 there it's 2, 2 there it's 1, 2 there it's 2. So the answer is 2 over 5. Calculate the probability that the beads selected are of different colors. So probability of different colors. So the probabilities, so when we look at the probabilities that are of different colors, this probability, it has same colors. This probability, it has same colors. So the probabilities of different colors, it is green, red, red, green. So these two probabilities, they are of different colors. So there we need to say probability of red, green, or probability of green, red is equal to, so I'll pick the two probabilities, or it means addition. So the probability of red, green is 4 over 15. The probability of green, red, it is 4 over 15. So we're going to say 4 over 15 plus 4 over 15. So remember that when denominators are the same, just go direct add or subtract. So 4 plus 4, that is 8. So that is the answer. B, the Venn diagram shows the number of elements of sets P, Q, and R. So this is set Q, set P, and set R. Find the value of X such that number of elements in P is equal to 18. Number of elements in P is equal to 18. So what are the elements in P? So the number of elements in P, we have X plus 1 plus 2X plus 1 is equal to 18. Okay, so these are elements that are in P. So when you look very well, set R is a subset of set P. That X plus 1, it is contained in set R as well as in set P. So there we correct the like terms. X plus 2X equals 18. This was positive 1. When it crosses the equal sign, it will be negative 1. This was positive 1. When it crosses the equal sign, it will be negative 1. So there we say X plus X, 2X. 2X plus 2X, we have 4X. 18 minus 1, 17. 17 minus 1, we have 16. So we divide throughout with 4. 4, so we have 4, 4 goes. So X is equal to 4 into 16, we have 4. So the value for X is 4. So part 2. So the number of elements that are not in R. N R complement. It means the elements, the number of elements that are not in R. So the number of elements that are not in R, we have 12. We have X. We have 2X plus 1. So these elements are not in R. So remember that we have the value for X. So we have the value for X. The value for X is 4 plus, where there is X, we substitute 4 plus 1. So 12 plus 4, 2 times 4, that is 8. Okay, so plus 8 plus 1. So 12 plus 4, that is 16. 16 plus 8, 24. 24 plus 1, we have 25. So part 3, number of elements that are in R union Q. So the elements that are in R and Q. So for R, we have X plus 1. Then for Q, we have 12 plus X. So the value for X is 4 plus 1 plus 12. The value for X is 4. So 4 plus 1, that is 5. 5 plus 12, that is 17. 17 plus 4, we have 21. Find number of elements that are not in P and in Q. The elements that are not in P and in Q, that is the meaning of the complement. So the number of elements that are not in P and in Q, it is 0. So that is the empty set. So you put up the symbol, that is the symbol for the empty set, or that is the empty set.